the end. I'm not sure which question it was, but 3 or 4 of us missed it, so I want to make sure we talk about it. Again, if 3 or 4 of us miss it using all of our chances, then I'm assuming that maybe some people missed it prior to using all their chances. It says, if possible, use the law of detachment to make a conclusion. It says, if it is not possible to make a conclusion, tell why. So basically, when they say tell why, we're going to be looking at, remember the law of detachment said, well, let me write it in kind of generic terms here. We're always going to be given a phrase, if P, then Q, whatever that may be. And in this case, it's if 3 points are on the same line, then they're collinear. Okay, so that's our P and our Q. The next thing with the law of attachment is that they're going to give you another phrase. If that other phrase matches P, okay, so it matches your hypothesis, okay, then you can say Q about that P. That's the conclusion you can make. Does that make sense, everybody? So when I read this, it says if 3 points are on the same line. So that's my hypothesis right there. Okay, 3 points on the same line. Then they are collinear. Okay. Now I'm going to look at the statement that they provide me, the additional statement they provide me, and what does that say? Does that tell me? Does that give me the same thing that I have written in red? Yes. Okay. Now it's not verbatim. It's not word for word. Okay. But idea for idea, that says the exact same thing, right? So then the conclusion I can make about A, B, and C is what? They are collinear, okay? Once these two things match, you gain that conclusion about the objects you're talking about in that second statement, okay? And that's what's going to be useful when we get to proofs and we want to create a new line of information as we look at the previous lines of information and see how we can interrelate them to create something new. And the new thing we could say now is, well, A, B, and C are collinear. And hopefully maybe that leads us somewhere else throughout the proof. Another one that was similar to that says if 3 points are not collinear, then they form a triangle. Okay? If 3 points are not collinear, then they form a triangle. So here it says there's my P value or my P statement. Okay? And then the second statement that goes along with the if-then statement is points R, S, and T are not on the same line. Okay? Well, is that what not collinear means? Yeah. So those two ideas do match. So what can you say about R, S, and T? They form a triangle. They're the vertices of a triangle. What if I had something like this, though? What if I said, we'll just say if 3 points are collinear, then they form a triangle. And I say points R, S, and T are the vertices of a triangle. Is there anything you can make a conclusion about with that statement, that additional statement about R, S, and T? Given the if-then that we started with. Okay? Because what we want to do, I see Tyler shaking his head no. What we want to do is see if that phrase there matches up with this, right? Okay. Now we do know that the 3 vertices of a triangle are not collinear, okay? But those two ideas do not match either one another, right? So there's no conclusion I can make, okay? Even if I said this, points R, S, and T are non-collinear, okay? There is still no conclusion that I can make. Does that make sense? And what a lot of people want to do, well, if they're non-collinear, okay, then I should be able to make the argument that they don't form a triangle, right? Can't do that, okay? The law of detachment says you cannot make a conclusion. And you saying that they do or they do not form a triangle is coming to a conclusion that statement does not want you to make. Does that make sense? Okay? And that's what I fear a lot in this class for students is when we say something isn't true, okay, or something that there's a conclusion that we can't make, they want to read into it and say, well, I can make this statement then, and you can't always do that. For instance, if I tell you, Like I give you an angle, like angle ABC, and I tell you it is not a right angle. Okay? Can you tell me what its measurement is?
No.
No, because there's so many different possibilities it could be, right? Okay? And that's the idea, what that last question was saying, is there are so many different things it could be. So the simplest thing we say is that there's no conclusion. Okay? When we look at the law of syllogism, okay, remember the law of syllogism said you had to be able to take a conclusion and it had to match a hypothesis, right? Okay. Now what happens is it doesn't always have to be in order of like statement 1 and statement 2. You know, statement 1's conclusion doesn't have to match statement 1's hypothesis. It is nice when they show up that way, but it could be statement 2's conclusion matches statement 1's hypothesis. So we might have to, it might be a little bit better maybe in some situations to put this first line second. Does that make sense? I'll give you an example of what I mean by that here in a moment. But what we're going to do is we're going to go through and read these two statements, and then we're going to find the hypotheses and conclusions of those respective statements. So, if the sum of the digits of a whole number is 9, then it is divisible by 3. If the sum of the digits of a whole number is 9, then it is divisible by 3. Okay? So take 81. If I add 8 and 1 together, I get 9, right? That tells me that 81 was divisible by 3. Does that make sense to everybody? Mm-hmm. Okay. So it's telling us to assume that these are true. And this here is the conclusion. Okay. And my hope is that it then is going to match up to that hypothesis. Okay. Which says if the sum of the digits of a whole number is 6, then it is divisible by 3. Okay. Do those two things match up? Divisible by 3 and sum being 6 are not the same ideas, right? Okay. So there's no conclusion that I can make looking at them in that order. Okay? So the next goal is to say, can I take this conclusion and that hypothesis, okay, and see if they match up. Do they match up?
Yeah.
Careful. They have to say the same thing. For the law of syllogism, they have to say the same thing. So adding a 9, is that to say the exact same thing as divisible by 3? No. Okay? If they're going to be the same, one's going to say their sum is 9, and the other one's going to say their sum is 9. Or one is divisible by 3, the other one is divisible by 3. They're going to say the exact same thing. So we can develop those ideas. Okay? So let me give you an example. If, and maybe a non-mathematical example, if it is fourth period, Tyler is in my room. And now if I write, if Tyler is in my room, I am sick to my stomach. Okay? And we're assuming both these are true, right?
Yeah.
Okay? And I'm going to put them in this order. Okay? Because this order of these two statements, if they're both true if-then statements, people are going to neglect that there is a possibility here for these to be the same. We want a conclusion to match a hypothesis. Okay? I should probably write my word then in here. Okay, we want a conclusion to match our hypothesis. So here's a conclusion, right? If this part is met, if he's in here, I'm going to be sick. Okay, if he's not in here, I'm perfectly healthy. Okay, we look at that conclusion and see, does it match that hypothesis? Being sick to my stomach, is it the exact same thing as fourth period? No. Okay, so there's no conclusion looking at them in that order. All right, but when we have that issue with law of syllogism, what we want to do is maybe look at them in this order. And now when I look at that conclusion, does that match up with that hypothesis? Okay, Tyler's in my room, Tyler's in my room. So now the new statement using the law of syllogism, because they match, the new thing I can say is that green phrase. If it's fourth period, then I'm sick to my stomach. Okay? It's all due to time. All right? And that's what I want you guys to understand when you look at these initially. For the law of syllogism, if they do not match, look at them in a different order. Okay? And then maybe you will get a match. All right? The law of syllogism, law of detachment, they're very, very, very useful things for us. And they're really the way we operate through our daily lives, okay? But we don't necessarily, every time we come across a situation in life and we have to make an action or something like that, we don't sit and think about how we consciously think. Does that make sense? Okay, right now we're thinking about the way we think, and usually it's just second nature for us to go through and make actions and decisions. Now we're going to slow things down and talk about them